Why can I see myself very clearly in this glass mirror, but with this glass window, I only see a faint reflection of myself in addition to through it? Most glass mirrors are backed with metals like silver because of their high reflectivity, meaning almost all of the light rays emitting off of my body will be reflected into my eyes. When light hits glass by itself, a small fraction of the light bounces off the glass, and the rest of the light continues through it, meaning very few light rays reflect into my eyes, allowing me to see that fainter reflection of myself. Engineers studied these aspects of ray optics to design the manual tilt version of rearview mirrors in cars. You've probably seen this little tab before, and maybe you even know that flipping it helps you not get blinded by another driver's headlights. But how exactly does it do it? What makes rearview mirrors distinct from other mirrors is that not only is it composed of a metal backing, but also a thick glass wedge. Because of the angle created by the wedge, there are two flat surfaces in which light can bounce off of, the highly reflective metal backing and the significantly less reflective glass surface. Let's take a look at the differences between the day mode and night mode positions of manual tilt rearview mirrors.
During the day, when the headlights of the cars behind you reach your mirror, these rays appear to be directly reflected at an angle that's oriented towards your eye. In reality, there is actually a small portion of the incoming light that does not reach your eyes. When your car rearview mirror is on day mode, the metal part of this mirror is tilted towards your eyes. At this orientation, 96% of the light from the incoming ray of the headlights will reflect off the metal at an angle that will reach your eye level. The other 4% will be discussed later as the dimmer light that is reflected off of the front pane of glass. As you can see in this diagram, there are two rays of light that are reflected, the brighter ray that is reflected off the metal and the dim ray of light that is reflected off the glass. Both of these rays exhibit the law of reflection as they create the same angle of incidence as their angle of reflection. The angle of incidence is indicated as being the angle between the incoming ray and the normal line, while the angle of reflection is the angle between the reflected ray and the normal. These respective angles are indicated by the dark and light blue angles for the metal and the dark and light purple angles for the glass. Light is passing through two indicated mediums, air and glass, both of which have separate indexes of refraction. When the incident ray goes through these two mediums, a refractive ray is created as a result. The relationship between the angles of refraction and the angles of incidence shown in the diagram can be described using Snell's law. The application of the Snell's law formula will be discussed when we talk about night mode.
We just looked at the physics behind the day mode of rearview mirrors, and now we'll examine how the night mode feature prevents drivers from being blinded by bright headlights. Switching to night mode dims the lights behind the cars by changing the angle of the reflected material behind the mirror's glass from one that reflects off the back surface into your eye to one that reflects off the front surface into your eye. This results in only about 4% of bright light being reflected into the driver's eyes at night instead of the daytime 96%. We can examine the physics behind this concept with a ray diagram which traces the path of light. First, the incoming light rays hit the back of the mirror, which is now pointing toward the dark ceiling of the car, so you don't actually see that bright light. Instead, what you actually see is the image reflecting off the front of the glass labeled dimmer light. As mentioned earlier, the law of reflection for flat surfaces can be applied to the night mode as well. As we can see from the ray diagram, the angle of incidence equals the angle of reflection for both glass and metal. Since light rays are passing through different mediums, Snell's law can be applied. Snell's law mathematically determines how a light ray bends when it's refracted. The light rays go from a medium of air to a medium of glass, which have different index of refractions. Air has an n value of 1.003 and glass has an n value of 1.52. Because light is going from a low to high index of refraction, it bends towards the normal, as seen by the red line labeled refracted ray. Plugging in those n values to Snell's law gives a ratio of sine theta 2 over sine theta 1, which is 0.66.
Now that we've looked at the math, why is this light dimming effect so important? Unfortunately, many fall victim to accidents because of glare created by headlights at night. A strong reflection, as simulated here, may disrupt a driver's normal view of the road, whereas this dimmed reflection is much easier on the eyes. It's quite alarming that this aspect of car safety isn't already embedded in driver's education, or at least not in California. Some don't even realize that the mechanism exists. So the next time you're driving and you feel blinded by the lights, give that tab on your rearview mirror a flip. It'll be sure to save your eyes, and potentially, some lives.